This naturalrefrigerants.com article is being read by an automated voice. Adaptation 2025. Novel technology may cut energy use of CO2. Refrigeration in hot climates by 14%, says study, by J. O. Haraldson, published September 10, 2025. In hot climates, a novel technology could reduce the energy consumption of commercial CO2 refrigeration systems by up to 14% compared to standard setups, according to new research from the University of Southern Denmark. The concept integrates a pressure booster device and an air-cooled gas cooler installed behind the existing heat rejection component and replaces the high-pressure expansion valve with an expander. Modeling demonstrated potential energy savings compared to conventional CO2 systems in Seville, Spain, and New Delhi, India. In Seville, average summer highs are between 35 and 40 degrees Celsius, 95 to 104 degrees Fahrenheit, and in New Delhi they frequently exceed 44 degrees Celsius, 111.2 degrees Fahrenheit. The findings were presented by Guru Chetan Matha, a postdoctoral researcher at USD at the International Institute for Refrigeration, IR's inaugural international conference on Refrigeration Adapting to Rising Temperatures, Adaptation 2025. The event, hosted by the Institute of Refrigeration UK, was held August 10th to 13th in Manchester, England. The combined solution results in an energy savings of 7.8% in Seville and 14.4% in New Delhi, with a return on investment, ROI, of roughly 3 years in both locations, Matha said. The design. The researchers broke the design into 2 stages. First, they installed the booster device, followed by an additional air-cooled cooler between the outlet of the air-cooled condenser, or gas cooler, and the inlet of the high-pressure expansion valve. Then they replaced the high-pressure expansion valve with an expander. The booster device, which Matha related to a pump, slightly increases the refrigerant's pressure with less electricity than a parallel compressor, with the air-cooled cooler returning the temperature to the previous outlet. The design reduces refrigerant vapor content and minimizes flash gas formation, lowering compressor load. Although the technology offers a cheap solution compared to other subcooling techniques, it provides only a marginal energy savings, according to Matha, with a 2.3 to 2.9% reduction in Seville and a 4.6 to 5.7% reduction in New Delhi. However, including the replacement of the high-pressure expansion valve with an expander, which Matha related to turbine technology, allows the recovery of energy and increases the COP by 8.5% at an ambient temperature of 23 degrees Celsius, 73.4 degrees Fahrenheit, and by 22.5% at 40 degrees Celsius. Modeling loads. The parameters used by the researchers for the comparison included a low-temperature, LT load of 35 kilowatts, 10 tons of refrigeration at minus 32 degrees Celsius, minus 25.6 degrees Fahrenheit, and a varying medium temperature, MT load, based on the ambient conditions of around 100 kilowatts, 28.4 tons of refrigeration, at minus 8 degrees Celsius, 17.6 degrees Fahrenheit. Economic assessment. Both the booster device and the expander are under development. Industry manufacturers provided cost estimates of the equipment, including €15,600, $18,300 for the booster device, €9,000, $10,600 for the expander, and €7,000, $8,200 for the air-cooled gas cooler. If the booster device operates with a 50% efficiency, it will take nearly 10 years for the return on the investment, Matha said, adding that at 65% efficiency, it will take 8 years. Adding the expander to recover energy cuts the ROI to 3 years based on operation with a 65% efficiency. Quotable. To further open the doors to supermarket, CO2. Applications in warm and hot climates. The literature highlights the need for simpler and more affordable technologies to enhance the performance of transcritical R744 refrigeration systems, Matha said. Our proposed technology requires relatively few additions with off-the-shelf standard components.